Now the question was asked like this. The unit of del cross H is option A ampere, option B ampere per meter, option C ampere per meter square, and option D ampere meter. Here the question asked was like this. The unit of del cross H. Just what I do is, first I will try to analyze what is del cross H which is given to us. Del cross H, that the curl of H, the magnetic field intensity. What are the units of our magnetic field intensity? Ampere per meter. So keep it in mind. Try to apply a curl to that one. That just I expanded the curl of this particular term. Now after simplification, don't go for any calculation. After simplification, for every term what we got is dou by dou y of hz minus a dou by dou z of hy. That is dou by dou of h, that what we are getting. So for every vector, that vector will be included there. Say dou by dou x for our understanding, that what I am considering distance of h. Dou h by dou x. Dou h by dou x means simply h by distance, that what we are getting. H by distance. What are the units of h? Ampere per meter. And what is distance? Meter. So if you take the units ampere per meter by meter, just it is ampere per meter square. Just you observe, the very simple it is that del cross H, if you take the expansion and take the units, just it is ampere per meter square. But remember, in any competitive examination, we are not supposed to take the conventional method. We are supposed to take the easiest way. If you remember the Maxwell's equations, then it is very easy to solve. So what is the Maxwell's equation which is related to this particular term? That what we got is del cross H. That the Maxwell's equations what we have is del cross H is equals to J plus dou D by dou T. This is our Ampere's law, right? So del cross H is equated to what? J. What is J? Current density. It's a clearly conduction current density. What are the units of current density? Current per area. That is simply ampere per meter square. The same we got. But if you follow this method, it is very easy to obtain the answer. So option C, that what we have is ampere per meter square, is right option. That we are supposed to mark option C as right answer. Now the second question was given like this. If C is a closure curve enclosing surface S, then the magnetic field intensity H bar and the current density Z bar and electric flux density D are related by. The options are like this. It's a surface integral of H ds. The surface integral what we are considering is open surface. Open surface integral of H ds is equals to closed contour integral of J plus dou D by dou T dl. And option B, open contour integral H dl is equals to closed surface integral of J plus dou D by dou T ds. And option C is closed surface integral of H ds is equals to open contour integral of J plus dou D by dou T dl. And option D is as a closed contour integral of H dl is equals to open surface integral of J plus dou D by dou T ds. Here the question was clear that he asked to relate the magnetic field intensity H and electric flux density D and current density J. So if you recollect the equations Maxwell, so what we have, the relation between H, J and D, is a beautiful equation that what we have is del cross H is equals to J plus dou D by dou T. So this is the basic equation which is remembered in our point form, but the options are given in integral form. So here what we are supposed to do is we are supposed to convert this differential form to the integral form. As I said, whenever you find curl, use Stokes theorem and apply ds as a differential surface integration on both sides. That what I do is I will take surface integral that del cross H ds is equals to, this is also surface integral of J plus dou D by dou T ds. That don't go for any closed surface integral, open surface integral. Surface integral of curl H ds is equals to surface integral of J plus dou D by dou T ds. Now, so on the left hand side what we have is a surface integral of curl. So you can convert that one into the closed line integral. So clearly this can be written as a closed line integral of h dl is equals to open surface integral. Even though I am writing only one integration, two integrations will be there. It is a two-folded integration since it is surface. Surface integral of that j plus dou d by dou t ds. So this may be the answer that what you are supposed to find out in the options. So if you observe option 4, that is a closed contour integral of HDL is equals to open surface integral of j plus dou d by dou t ds is the right. So we are supposed to take that option D as answer. And the next question was asked like this. The Maxwell's equation del cross H is equals to j plus dou d by dou t is derived from or is based on. Option A is Ampere's law, option B is Gauss law, option C is Faraday's law, and option D is Coulomb's law. So here clearly we are supposed to observe what is the equation which is given to us, and it's a very familiar equation. Del cross H is equals to j plus dou d by dou t. This is the equation. Based on which law it was derived? Just remember, whenever the extra term was added by the Maxwell, it is simply Ampere's law. So inconsistency in Ampere's law was removed or eliminated by Maxwell by adding a simple term, that is dou d by dou t. This dou d by dou t is the displacement current density. Since it is an extra one which is added by our Maxwell, so clearly this is our Ampere's law. So option A, that what we are supposed to identify in that particular bit. The next question was asked like this. For static electric and magnetic fields in an inhomogeneous medium, and it is a source free medium, which of the following represents the correct form of Maxwell's equations? Option A, del dot E is equals to 0 and del cross B is equals to 0. Option B, del dot E is equals to 0 and del dot B is equals to 0. Option C, del cross E is equals to 0 and del dot B is equals to 0. Option D, del cross E is equals to 0 and del dot B is equals to 0. So just you observe what is the type of medium which is given to us and what are the conditions. Clearly a static electric field is given to us. So that the E and H are given for static fields. Static electric field as well as a static magnetic field. And the medium what we are considering is inhomogeneous medium. Since it is inhomogeneous medium, clearly remember that the epsilon and mu will purely depend upon the spatial quantities. It is not homogeneous medium, so we are not supposed to take them out from the dou by dou t operation or del operator as our wish. Remember that point also. So which of the following equations represents the correct form of Maxwell's equations? So what we do is we will try to write down the equations of our static fields and we will try to correlate them. So for static fields, clearly for inhomogeneous medium, as we discussed, inhomogeneous medium will consist of epsilon in its operator. So del dot D is equals to rho V, that's what we are supposed to take. But here it is mentioned as a charge free or source free medium. Since it is source free medium, this must be equals to 0, that is our first equation. So del dot D is equals to 0. Identify that one. We couldn't find any del dot D is equals to 0. So leave it. This is not the equation which is required for us for this particular question. Second equation, del cross E is equals to 0. We are not supposed to modify this equation. The del cross E is equals to 0, since it is static, is equals to 0 is considered. So observe this one, just we have this del cross E is equals to 0 in two options, that is in option C and option B. So keep it aside. And the third equation that what we have is del dot B is equals to 0. Since it is inhomogeneous medium, we are supposed to write down this one as del dot B is equals to 0. Don't write it as del dot H is equals to 0. And observe whether it finds in our options or not. Yes, we have that del dot B is equals to 0 in option 4, option D, right? But try to identify the next one also, that del cross H is equals to, since it is source free region, sigma will be equals to 0 and dou D by dou T, that what we have, which is equals to dou D by dou T, that's directly I am writing. But it is static field, right? So since it is static field, simply it is equals to 0, that del cross H is equals to 0, that what we have. Now identify which option suitable for us. Clearly del cross E is equals to 0 is available, del dot B is equals to 0 is available in option 4. So clearly these two equations are suitable for a static inhomogeneous medium. So option D is right option. So clearly identify that one purely based on our Maxwell's equations. So the next question was asked like this. A loop is rotating about y-axis in magnetic field B, which is equals to B naught cos omega t plus phi AX Tesla, and the voltage induced in the loop is option A 0, option B due to rotation nature only, option C due to transformer action only, and option D due to both rotation and transformer action. So these are the four options which are given to us, and here clearly a loop is given which is rotating about y-axis. So clearly a loop is there which is rotating about y-axis, and the magnetic field is also given to us. That magnetic field is a time varying magnetic field, right? So clearly B, the magnetic field is a time varying magnetic field. What is the expression for this one? How we can say that it is a time varying? B naught cos omega t plus phi, that this B naught is the constant, it's the initial magnetic field intensity. Cos omega t plus phi describes the time varying nature of the magnetic field. So B is time varying one, right? So whenever the B is time varying, it is a time varying field. So since it is a time varying field, clearly recollect it is a generator action, right? And the second one, it is a rotating loop. The loop what we have is rotating along y-axis. Since it is rotating along y-axis, clearly you can say that ds is also varying, that ds is also a function of time. So here clearly observe, in that particular phenomena or the quantity, ds is a function of time as well as b is a function of time. So the voltage which will be induced in that particular loop is a combination of both transformer action as well as our rotation nature. So option D, that say is correct here, that is due to rotational nature and transformer nature, clearly the potential will be induced. So option D is correct. Now the next question was asked like this. Here a sentence was given, an assertion was given, and a reason was given, and we are supposed to observe whether the reason is suitable for that assertion or not. The assertion is given like this. Time varying electric field produces magnetic fields, and the reason for that is given like this. The time varying magnetic field produces electric field. So here clearly the two statements are given like this. The time varying electric field produces magnetic fields. This is the assertion. And the reason is the time varying magnetic field produces the electric field. The options are like this. Both A and R are true, and R is correct reason for A. And the option B is like this. Both A and R are true, but R is not correct option for A. Option C is A is true, but R is false. Option D is A is false, but R is true. Here clearly observe what are the statements given to us. The time varying electric field produces magnetic field. That what we have is a time varying electric field, that a dou E by dou T, that what we have. The time varying electric field produces magnetic fields, that we have our Ampere's law and Faraday's law, which gives our radiation. From the Faraday's law, dou E by dou T is equals to, clearly we can write, which is related to somewhat a del cross H, or some constants will be there. No need to go for constants for time being, just a time varying electric field can generate a rotating magnetic field from our Faraday's law. In the same way, from our Ampere's law, dou H by dou T is equals to, del cross E, this is from Faraday's law, and this is from our Ampere's law. From the Ampere's law, del cross H is equals to dou E by dou T, and from our Faraday's law, del cross E is equals to dou H by dou T. So clearly those two statements are right. Assertion is right as well as reason is also right. But clearly remember, so no one is depending on another. It is independent of this one, it is also independent of this one. So clearly R is not a correct reason of that assertion. So option may be like this. Both A and R are true, but R is not the correct explanation for our A. So clearly option B is right answer. So option B we are supposed to identify. The next question was given like this: which of the following Maxwell's equations gives the basic idea of radiation? That a set of equations were given and he asked to identify which of the following equations were describes the radiation among the all equations. That option A is del cross H is equals to dou D by dou T in combination with del cross E is equals to minus dou B by dou T, and option B is del cross E is equals to minus dou B by dou T, del dot D is equals to minus dou B by dou T. Option C is del dot D is equals to rho V and del dot D is equals to 0. Option D is del dot B is equals to rho V and del cross H is equals to dou D by dou T. So here we are supposed to identify among all the equations which are most suitable for observing or understanding our radiation. As we discussed, the Ampere's law and Faraday's law, these two are most suitable. From the Ampere's law, directly we can write del cross E is equals to minus dou B by dou T, that what we have, del cross H is equals to dou D by dou T. So here I am ignoring that conduction current density J because the radiation may be in free space, that for free space sigma is equals to 0. So clearly if you have these two equations, that is del cross E is equals to minus dou B by dou T and del cross H is equals to dou D by dou T, clearly we can understand the phenomena of radiation. So clearly these two equations appears in our option A. So option A is correct answer. That option A is right. In the next question, it was given like this: the magnetic field intensity is H is equals to 3AX plus 7YAY plus 2XAX ampere per meter. Then what is the current density J in ampere per meter square? The options are given like this: minus 2AY is the first option, and option B is minus 7AX, option C is 3AX, and option D is 12AY. Here clearly H is given to us, we are supposed to identify the current density. So what is the equation of H? H is equals to 3AX plus 7YAY plus 2XAZ ampere per meter. So this is the equation of H which is given to us. We are supposed to calculate current density. Which current density we are supposed to observe? That clearly remember the total current density. So what is the equation which relates our current density with H? That we have a beautiful equation, del cross H is equals to J. So that is the total current density we are observing here. So if you find the curl of this particular vector which is given to us, then obviously that is our current density. So just expand this one. That is in the left hand side, AX, AY, AZ, they are the unit vectors. For the del operator, dou by dou X, dou by dou Y, dou by dou Z, and the components of our H. The X component is 3, Y component is 7Y, Z component is 2X. Just calculate this one, which is equals to AX, dou by dou Y of 2X, 0, dou by dou Z of 7Y, 0. So simply 0 minus 0, that what we get, minus AY, dou by dou X of 2X, that simply it is 2 minus dou by dou Z of 3 constant, which is equals to 0, plus AZ into dou by dou X of 7Y, 0, dou by dou Y of 3, which is also equals to 0. So simply which is equals to minus 2AY ampere per meter square. Just don't ignore these units. The current density units are ampere per meter square. That minus 2AY answer appears in option A. So clearly option A is correct answer for this particular bit. In the next question, it was asked like this: which of the following is not a Maxwell's equation? 4 equations are given to us. We need to identify which equation is not Maxwell's equation. Option A, del cross H is equals to sigma plus j omega epsilon multiplied with E. Option B, F is equals to Q into E plus V cross B. And option C, a contour integral, a closed contour integral of HDL is equals to surface integral of JDS plus surface integral of dou D by dou T ds. And option D is closed surface integral of BDS is equals to 0. So don't go for any other, just recollect what are the options given to us. Here we are supposed to identify, so which one is not Maxwell's equation. So we must familiar with Maxwell's equations in all forms. The first option, del cross H is equals to sigma plus j omega epsilon E. This is called as Ampere's law in phasor form. that this is a Maxwell's equations which is written in our phasor form. So clearly this is a Maxwell's equation. And come to the option B. In option B, that what we have is some force. And clearly remember, till now we didn't gone through any force in our Maxwell's equation. That we gone through the electric field, magnetic field, electric flux density, magnetic flux density, conduction current density, etc. But we didn't gone through any force, right? So keep it aside. That may be some equation, right? F is equals to Q E plus U cross B. So this is related to force, that may not be Maxwell's equation. Keep it aside. Go to the option C. In option C, that what we have is closed contour integral of HDL is equals to surface integral of JDS plus surface integral of dou D by dou T. So option A and option C, these two are same options, but one is written in phasor form, another one is written in integral form. So this is also Maxwell's equation. And come to the fourth option, that is surface integral of BDS is equals to 0, which gives the integral form of our non-existence of magnetic monopole, which is also Maxwell's equations. So clearly option B is not suitable here, that it is not at all a Maxwell's equation, just it describes the force acting on a charge in presence of both electric field and magnetic field. So clearly option B, that what we are supposed to observe as not Maxwell's equation. That is the answer for this question. In the next question, the data was given like this. In free space, if rho v is equals to 0, the Poisson's equation becomes Maxwell's divergence equation del dot B is equals to 0, that is the first option, and Laplace equation del square V is equals to 0, this is option B, and option C is Kirchhoff's voltage equation sigma V is equals to 0, and option D is none of the above. Here what we are supposed to do is we are supposed to recollect what is our Poisson's equation, what is our Laplace equation. How the Poisson equation was described. Take your Gauss law, that is del dot D is equals to rho V. That del dot D is equals to rho V can be modified as del dot epsilon E is equals to rho V, and this E can be replaced with the equivalent of its potential, that del dot epsilon minus gradient of V is equals to rho V. This epsilon can be brought out from the differential operator if it is a homogeneous medium. But what is the type of medium which is given to us? It's a free space. Clearly it is a homogeneous medium. Since it is homogeneous medium, this what we can write as minus epsilon del dot del V is equals to rho V, that del square V is equals to minus rho V by epsilon. So simply this is the Poisson's equation that what we have. Now this Poisson's equation can be written for free space and for charge free region. If it is charge free, that is rho V is equals to 0, simply del square V is equals to 0, that is called as the Laplace equation. So whenever we are modifying the Poisson's equation for charge free and free space, clearly write down this del square V is equals to 0. That option B describes this one as Laplace equation del square V is equals to 0. Therefore option B is correct answer for this question. So this is a very simple question, that like this we have many number of questions which will be framed on our Maxwell's equations, that different form of Maxwell's equations will be given and we are supposed to interpret them. Or on the left hand side, the Maxwell's equations will be given either in point form or differential form in any medium. And on the right hand side, the interpretation or basic law which is related to that Maxwell's equations will be given. You are supposed to ask the match them. So what you need to do is you need to identify, so what is the basic equation what we have in the differential form, and how to convert them into the integral form, and what is the basic equation or basic law which is used for deriving the first equation. So if you correlate all these things, then it is easy to remember all these Maxwell's equations, and it is very easy to solve all the questions which are related to the Maxwell's equations.